Hello guys, welcome to my channel Algorithm Avenue. In our previous two videos, we have worked on two problem domains. One is binary classification and another is multi-class classification. Now let's work on the third problem domain, that is linear regression. Now, so to understand this linear regression, we have taken an example dataset, that is low diabetes dataset. Okay, this low diabetes dataset consists of 442% samples. Okay, 442% samples with 10 features. Okay, with 10 input features, let's say age, BMI, blood cholesterol, etc. And so our aim is to predict the, basing on this 10 input features. Okay, basing on this 10 input features, our aim is to predict the diabetic level of a person. Okay, in this dataset we'll be having 442% data with 10 input features, now basing on this input features, our aim is to predict the person diabetic level. Okay, so to solve this dataset, the neural network I personally took is this neural network. Okay, this is a neural network I personally took. Okay, I personally took to solve this dataset. Okay, now in this dataset, okay, in this neural network, sorry, in this neural network we have 10 input features. Okay, we have 10 input features. Okay, we have 10 input features ranging from xi1 to xi10. Okay, xi1 to xi10, and followed by an hidden layer. Okay, followed by an hidden layer with 128 hidden units. Okay, with 128 hidden units, and followed by an output layer with one output node. Okay, with one output node. So in conclusion, we can say that it is a two-layered neural network. Okay, in conclusion, we can say that it is a two-layered neural network. Why we have 10 inputs in our input layer is we have 10 input features. We have 10 input features in our dataset. Okay, so that is why we have 10 input nodes. Okay, 10 inputs in our input layer. Okay, followed by an hidden layer we have 128 hidden units. Okay, we have 128 hidden units, and followed by an output layer we have one output node, because we have only one label. Okay, we have only one label, that is diabetic level, in our data set. Okay, now let's solve this, data set with our neural network in our computer screen.
In the previous section of the video, we have seen the intuition of the diabetes dataset, and we also build a custom neural network to work on this dataset. Now, in this section of the video, what we will be doing is we'll be importing the dataset from an external website. Okay, we'll be importing the dataset from an external website, and we'll be building a model which works on this dataset. Okay, we'll be applying the the model that we build to this diabetes dataset. Okay, now our first and initial step is we import torch library. Okay, we import torch library. Why do we import this torch library? Is we in PyTorch generally we work on tensors. Okay, this torch library is efficient. With this torch library efficiently handles the tensors, so that is why we import torch library. Okay, now to import our dataset, we write this part of the code. Okay, this part of the code is written to import the dataset from an external website. Okay, that external website is sklearn.datasets. Okay, this sklearn.dataset contains n number of datasets. From that dataset we are importing low diabetes dataset. Okay, now once I'll be showing you the website. Okay, this is the website. Okay, this is the website, that is sklearn.datasets. Will be having a number of datasets. From this datasets I have imported low diabetes. Okay, low diabetes dataset. Okay, in the next part of the code I am importing pandas. Okay, pandas library. Now after importing the datasets from an external library, what I did is I have created an object diabetes. Okay, I have created an object diabetes, and I have loaded that entire dataset into diabetes object. Okay, I have loaded the entire dataset into diabetes object. Okay, now after loading it into diabetes object, I divided the data into features and labels. Okay, features and labels. Okay, I have separated the data into features and labels. Okay, the entire features are stored in X. Okay, the entire features are stored in X, and entire labels are stored in Y. Okay, means this entire data, okay, from here, okay, from age to S6 is stored in X, and this target variable is stored in Y. Okay, now in this part of the code I'm creating this data frame. Okay, I'm creating this data frame. First I'll be showing this, I'll be removing this and I'll be showing you the data. Now let me write diabetes. Okay, let me print this diabetes dataset. Yes, you see that it is in the form of numpy. Okay, it is in the form of numpy arrays. Okay, when it is in the form of numpy arrays, it becomes harder for us to visualize. Okay, generally numpy arrays are harder to visualize. So the data that is in numpy arrays, we are converting it into data frames. Okay, we are converting into data frames for our better visualization. Okay, so that is why I have created a data frame. I have created a data frame, and okay, I have created a data frame and I am printing the data frame. Yes, this is our data frame which has age, sex, BMI, BP, S1, S2, S3, S4, S5, S6 as my features, and target is nothing but the diabetic level. Okay, target is nothing but the diabetic level. Okay, that is my label. Okay, these all are my features and this is my label. Okay, this S1, S2, S3, S4, S5, S6 is nothing but that is cholesterol levels. Okay, blood cholesterol levels, that may be good cholesterol, bad cholesterol, and blood sugar levels and blood fat levels. Okay, these all comprise S1, S2, S3, S4, S5, S6. Okay, this target is nothing but our diabetic level. Okay, in this way I have first imported our data into our Google Colab, and after importing the data to Google Colab, I have loaded the data into diabetes object, and after loading it into diabetes object, I have divided into labels and okay, I have divided into features and labels. Okay, the features are stored in X and labels are stored in Y. After dividing it into label features and labels, I have created and data frame for visualization purpose. Okay, our data is generally in the form of, initially our data is in the form of numpy array. From that numpy array I have created an data frame. Okay, I have created an data frame for better visualization purpose. As we have divided our data into X and Y, now let's check the shapes of the X and Y. Okay, for that we are writing X dot shape and Y dot shape. Okay, when you write X dot shape, this is our shape of the X. Okay, and this is the shape of the Y. Okay, this 442 determines that there are 442 persons in our data set. Okay, there are 442 persons data in our data set. Okay, this is the first person, the second row determines the second person, third person, fourth person, like that we have 442 persons data. Okay, 442 persons data, and this 10 determines that we have 10 features in our data. Okay, we have 10 features in our data. Okay, when you write y dot, when you run y dot shape, it shows 442. That is, we have 442 target, different target numerics. Okay, this 442 are different target numerics, that is 151 to 57. Okay, 151 to 57 we have 442. Okay, we have single target variable, so it is printing nothing over here. Okay, these are the shapes of X and Y. Now after understanding the shapes of X and Y, in the next step of the code, what we have done is we have converted from numpy to tensors. Okay, initially I have said that our PyTorch efficiently works on tensors, so we have converted from numpy to tensors. Okay, now x and y is converted from numpy to tensors. After converting from numpy to tensors, we have converted them to float values. Okay, first we have initially converted from numpy to tensors. After numpy to tensor conversion, we have converted the tensors to float values. Okay, float data type. Okay, till this part we have completed the conversion. Okay, type conversion. After completing the type conversion, we are ready to split our data. Okay, we are ready to split our data into training and testing split. Okay, we are ready to split our data into training and testing split. Okay, for that sklearn.model selection import train test split. Okay, we are dividing into training some part of the data into training and some part of the data into testing. Okay, this is the order that we have to follow. Okay, first we divide x variable and then we divide y variable that into x train and x test, and y train and y test is equal to train test split. Okay, train test split, what we want to split x and y, so we have given uh, we have given the data as x comma y. Okay, x comma y, and our test size is 0.2, means 80% of our data is going to training and 20% of our data is going to testing. Okay, the test size must be, okay, when you want to alter your test size, it must be around from 0.1 to 0.3. Okay, this gives us better predictions. Okay, I have taken 0.2, you may take 0.1, 0.3. Okay, now random state is equal to 42. Now I am printing the shapes of the x and y. Okay, x train y train and x train x test y train y test. Okay, when I see the shapes of the x train x test and y train y test, out of 442 persons, out of 442% persons, 353 persons are divided into x train and 89% are divided into testing. Means out of 442%, 353 persons are given into x train, and another remaining 18 persons are given into test. And another y train, in y train we have 353, means 353 persons are given for training and 18 persons are given for testing. Okay, this train test split happens randomly. Okay, this train test split happens randomly. Okay, now these are the shapes of x train x test and y train y test. After splitting your data into training and testing split, now what you have to do is you have to analyze your dataset. Okay, you have to analyze your dataset. Do you have any larger values? Okay, do you have any larger values? Okay, if you have larger values, then you need to scale your data between certain range. Maybe that may be 0 to 1 or -1 to +1. Okay, now in the next part of the code, what we'll be doing is we'll be scaling our data. Okay, now for scaling our data, we are using standard scalar process. Okay, standard scalar process. From sklearn.preprocessing import standard scalar. This standard scalar is loaded into this scalar object. Okay, standard scalar is loaded into this scalar object. Now we are scaling our x train and x test and y train and y test. Okay, in this parts of the code, we are training our x train and x test and y train and y test. Okay, after scaling operation, our pre-processing of the data is completed. Okay, until this we have entirely pre-processed our data. Okay, we have pre-processed our data, and now our model is ready. Okay, sorry, our data is ready to enter into our model. Okay, to enter into our model. Now in the next part of the video, okay, sorry, in the next part we will be building our model. Okay, we'll be building our model. Now from torch import nn means neural networks. Okay, nn means neural networks. From torch import nn. This helps us to build the custom neural networks. Okay, this helps us to build the custom neural networks. Okay, now we are creating a class that is diabetes model. We are creating a class that is diabetes model. You can give your any name. Okay, you can give any name of your wish, and we are subclassing nn.module. Okay, we are subclassing nn.module, and this is our constructor. Okay, this is our constructor, and the arguments are, okay, self is our default argument for the constructor. Okay, self is the default argument for the constructor, and these three are some extra arguments. Okay, these three are some extra arguments, that is input features, output features, and hidden units. Okay, next is super.init and self.linear model is equal to nn.sequential. Okay, this nn.sequential helps in linear flow of the data into the model. Okay, sequential flow. Okay, it helps in sequential flow of the input data. Okay, like first from input layer to hidden layer to next hidden layer, next hidden layer to next hidden layer, and then to output layer. In this way it follows in sequential way for the data flowing. Okay, now this is our first layer. Okay, this is our first layer, and this is our second layer. Okay, the custom neural network that we are taking is a 2-layer neural network. Okay, we are taking is a 2-layer neural network with one hidden layer and one output layer. Okay, the activation function for the first chain layer is ReLU. Okay, the activation function we are taking for the first chain layer is ReLU activation function. Okay, ReLU activation function, and this is our output layer. Okay, this is our output layer, and this is our hidden layer. Okay, this is our hidden layer. Okay, now we are calling the forward method. Okay, we are writing the forward method for the forward propagation of the data. Okay, for the forward propagation of the data. And now here we are creating a model instance. Okay, we are creating a model instance, that is model 2. Okay, model 2. Now we are loading our entire model into this model 2. Okay, model 2 object. Okay, we are loading our entire model into model 2 object. Okay, before loading our model into model 2 object, what we have to do is we have to determine the number of input features, number of output features, and hidden units. Okay, now the number of input features, okay, means the total number of features we have in our dataset is 10. Okay, you see over here we have 10. Okay, we have 10 features, and the number of output features in our dataset is 1, because we have only one label over here, right? Okay, we have only one label over here, so we'll be having one node in the output layer. Okay, we'll be having one node in the output layer, so that is why we have taken 1. And the number of hidden units, okay, the number of hidden units in the hidden layer is 128. Okay, the number of hidden units in the hidden layer is 128. Okay, now we have 10 input features. Okay, 10 input features and 128 hidden units in our first hidden layer, and in an output layer we have one output unit. Okay, now when you run it, it shows the model summary. Okay, it shows the model summary that we have 10 input features and 128 hidden units in the hidden layer, and from the output from that 128 hidden units will be passed to the one output unit in the output layer. Till here we have created our model. Okay, until here we have created our model. Our next step is to determine the loss function and optimizer. The loss function that we are using is MSE loss. Okay, the loss function that we are using is MSE loss, and the optimizer that we are using is Adam optimizer. Okay, why we are using MSE loss is, generally while working on linear regression, we use mean squared error loss. Okay, we use mean squared error loss. So that is why for our problem statement is linear regression, so we are using MSE loss, and the optimizer is Adam optimizer with learning rate 0.01. Okay, our optimizer is Adam optimizer with learning rate 0.01. Okay, after determining the loss function optimizer, we need to create training and testing loop. Okay, we need to create the training and testing loop. Okay, before creating the training and testing loop, we are again doing the type conversion. Okay, we are again doing the type conversion, because after the training and test split, for the what we say, for the consistency in the data. Okay, for the consistency in the data, after the training and testing split, we again do the type conversion. Okay, okay, this time not from numpy arrays to tensors, but from tensors to float 32. Okay, from tensors to float 32. Okay, after doing this type conversion, we build our training and testing loops. Okay, Okay, now the epochs that we are taking is 200 epochs. Okay, we have taken 200 epochs, and first from here to here this is our training loop, and from here to here this is our testing loop. Okay, this is our training loop and this is our testing loop. Okay, now to set into training mode, we need to write model underscore 2 dot train. Okay, in this part we set our model to training mode. Okay, we set our model to training mode, and we directly send our xtrain. Okay, we directly send our xtrain into model 2, and y preds are calculated by our model. Okay, y preds are calculated by our model. Okay, now loss is calculated between y preds, that is predicted output and true output. Okay, between predicted output and true output our loss is calculated, and this we set our gradients to 0, and this is our back propagation step. Okay, this is our back propagation step. Okay, now this is our optimizer dot step. Okay, optimizer dot step is used to update the model parameters. Okay, update the model trainable parameters. Okay, what it does is, after the updation of model parameters, for the next epoch, again these new updated parameters are applied into our model. Okay, are applied into again gradient calculation. Okay, are applied into again new weights and bias calculation. Okay, now this part of the code is written because after this training, after the model training, we'll be getting an fixed weights and bias, right? Okay, fixed weights and bias. Okay, again at the time of testing, you need not calculate the weights and bias again. Okay, you need not calculate the weights and bias. So to turn off this gradient calculation, we set our model to evaluation mode, and we set into our inference mode. Okay, we set into evaluation mode, and from evaluation to testing. Okay, that is inference mode. Okay, that is why in the testing we don't calculate gradients. Okay, we don't calculate gradients, but at the time of training we need to do the gradient calculation, and we need to determine the fixed weights and bias values, so that it is used at the time of testing. Okay, similarly we calculate test splits and test loss, and we print the model results over here. Okay, we are printing the model results over here. as we have initially taken basic model, you see that the training loss and test loss is little bit high. Okay, it is a bit high because we have taken a basic model, means we have not taken a deeper neural network but a basic neural network, so our training loss and test loss is little bit high. Okay, but when you increase the number of epochs, our training loss and test loss is getting down. Okay, our training and testing loss is getting little bit down. Okay, now you can improve this model performance. Okay, you can improve the model performance by building a deeper neural network and take number of hidden units and change the and alter the learning rate, so that our training and test loss, okay, our training and test loss gets to minimum. Okay, gets to minimum. Okay, now after building our model and building training and test training and testing our model, our next step is to test our model predictions. Okay, test our model predictions. Okay, how do we test our model predictions? First, we initially send xtrain. Okay, xtrain at 0th index means we are sending our first row data. We are sending our first row data in the xtrain to our model. Okay, we are sending our first row data into our model, so that our so that and predicted value is calculated over here. Okay, and predicted value is calculated over here. The predicted value by the model is 0.147. Okay, 0.147. Now corresponding to this first row, okay, first row of the xtrain data will be having an y train data, right? Will be having y train data, that is target variable. Corresponding this input data will be having an output data in the in our dataset. Okay, that is 0 minus 0.129. Okay, this is our true output and this is our predicted output by our model. Okay, this is our predicted output and this is our true output by our model. You see that there is a lot of variation in the predicted and true output, so this can be reduced by building a deeper neural network. Okay, okay, hope you guys like this video. If you like the video, please like, share and subscribe. Thank you.